Hello future engineers, subscribers, viewers, and students. Here is another video in structural analysis, or this may also be part of mechanics of materials. This is about beam deflections. This is the series of solutions to just one problem, and this time I present the virtual work method of computing the slopes and deflections at specified points in this beam. There we go. This is the original problem. The beam is subjected to the load shown if EI is constant. Determine the slopes and deflections at points A, B, C, D, and E by the virtual work method. So this is the original beam and the loadings. We have this trapezoidal loading 30 kilonewton per meter to 15 kilonewtons per meter, and we have a 12 kilonewton load here and this 15 kilonewton load. The reactions from the previous problems, or I want you to verify these reactions. So at A, 107 over 3 kilonewtons, and at D, 353 over 6 kilonewtons. So first, for the slope at A, the positive direction of slope is counterclockwise, so that's why by virtual work method, I apply a unit load here, which is counterclockwise couple of unit 1 kilonewton meter. Then the reactions would be reaction at A times 9 equals 1, so this is 1 over 9 upward. Then of course, this should also be 1 over 9 downward at B. Then these are the sectioning, section 1, section 2, 3, and section 4. There are 4 sections. There are 4 variations in the loadings. So this is the general formula, EI times 1 times rotation theta equals summation of integral 0 to L of Mamma Mia, or mm dx. So where capital M is the moment at a segment of the beam due to the real actual loads, and the M sub theta is the moment at the same section of the beam due to the unit couple applied. And for the deflection, EI times quantity 1 times delta equals summation of integral of same moment as this, and this M here is the moment at the section of the segment of the beam due to the unit upward load. So for theta A, so EI 1 times theta equals, for this section here, for this segment, the moment, of course, remember the sign convention, positive at the left clockwise, at the right counterclockwise, or any convention as long as you consistently apply that sign convention. So if you want clockwise always positive, then for the unit load, the clockwise moment should also be taken positive. And in the right section, also clockwise positive, then you can also do that. But I'll just prefer the proper sign convention, that is clockwise moment at the left positive, counterclockwise moment at the right positive. So EI times 1 times theta A equals, so the moment at this section 1 here is, since it is clockwise, 107 over 3 times x, which is this, limits of x 0 to 3 because the length of the segment AB is 3. Then for this section here, so we have 1 over 9 times x, then minus 1, so minus 1 dx. Then the integral at this section is 0 because although there is moment about this section due to the actual load, but due to the unit load, there's no moment here, so 0. That's why the integral is 0. Then for the next section, which is section 3, the moment is, remember, counterclockwise positive at the right. So 353 over 6 integral from 0 to 3 of quantity 353 over 6 times x, which is this, then minus 50 times 2 plus x. And that's it. Then due to the unit load, it is negative 1 over 9 times x. This is clockwise, so that's why it's negative for the right section. Then for the last section, section 4, due to the unit load, by the way, I'll call this W4 for the triangular loading. So by similar triangles, W4 as to x equals 30 minus 15 is 15 kilonewton per meter as to 3. So W4 is 5x. So the moment at this section is equal to 353 over 6 times 3 plus x, integral 0 to 3, 353 over 6, quantity 3 plus x, minus 15 times 5, 2 plus 3 is 5, 5 plus x. Then minus the moment of this load, 12 times x, minus the moment of the rectangular loading, 15 times x over 2, so that's 7.5 x squared, minus the moment of this triangular loading, 1/2 of x times W4, 1/2 of x times W4, which is 5x, then the moment arm is x over 3. Then that's due to the actual loads. And for the unit loads, the moment at this section 4 here is negative 1 over 9 times quantity 3 plus x dx. So using your high-tech calculator, the first integral is negative 749 over 6. The second integral is 0, of course. Then at section 3, the integral is negative 173 over 6. Then at the last section 4, the integral, the value is negative 547 over 3. So adding negative 749 over 6 minus 173 over 6 minus 547 over 3. So theta A is negative 336 over EI, just like before. Next, for the deflection or the rotation at B, theta B. So this is the beam, then we apply a counterclockwise unit couple again, 1 at B. So we always assume that the rotation is positive. Then the reaction should be, this is still 1 over 9 upward if we sum up moment here. So reaction times 9 equals 1, so 1 over 9 upward. Then reaction downward times 9 equals 1, so that's why this is 1 over 9 also, or you sum up forces vertical. So EI times 1 times theta B equals the moment at this section, you just copy the big N before, then due to the unit load, the moment at this section is still 1 over 9 times x. The integral of the second section is still 0 because there's no moment here due to the unit load. Then at the third section, you copy the moment big N as before, which is this. Then the moment at this section due to the unit load is negative 1 over 9 times x. Then for the last section, copy the big N, then the moment at this section is negative 1 over 9 times 3 plus x. This is this. So using your high-tech calculator, this is the same as, this is 107 over 3. The second integral is negative 173 over 6. And the last integral is negative 547 over 3. So combining this value, 107 over 3 minus 173 over 6 minus 547 over 3, it's negative 175.5 over EI for theta B. So just same value as before by the preceding methods. Next, for the deflection at B, we apply a unit upward load at B. This is it. Then the reaction here is you sum up moment about this right support D. So downward reaction times 9 equals 1 times 6. So 6 over 9 is 2/3, which is this. So downward reaction times 9 equals 1 times 3. So that's why this is 1 over 3 downward. So for EI times 1 times delta P, it is integral from 0 to 3. Copy the moment at section AB, big N. This is now the moment at this section due to the unit load, negative 2/3 of x dx. The moment at section 2 is still 0. Then plus at this section, copy the big N. Then the moment at this section is now negative 1/3 times x. And finally, at section 4, copy the big N. By the way, this is 5x cubed over 6. 5x cubed over 6. Then the moment at this section 4 is negative 1/3 times moment arm 3 plus x, considering the forces at the right. So, using your high-tech calculator, the first integral is negative 214, the second negative 173 over 2, and the third integral is negative 547. So combining negative 214 minus 173 over 2 minus 547 is equal to negative 847.5 over EI. So that's the deflection at B. So next, for the rotation at C, so we apply a unit couple at C. This is counterclockwise, assume always positive. So the reaction here is again 1 over 9, and this is 1 over 9 downward. If you sum up moment about this D here, so you can easily verify that. So the first integral, EI 1 times theta C, copy the original big N, then the moment at section is the same, 1 over 9x. The moment at section 2 is still 0. At section 3, copy the big N. Then the moment at this section is negative 1 over 9 times x dx. Then copy for section 4, copy the original big N. Then the moment at this section is equal to 1. There is positive 1 here. Then minus 1 over 9 times quantity 3 plus x. So using your high-tech calculator, the value of the first integral is 107 over 3, second integral negative 173 over 6, and the last integral 4345 over 24. So combining 107 over 3 minus 173 over 6 plus 4345 over 24 is 187.875 over EI for theta C as before. Next is for the deflection at C. So we apply an upward unit load 1. So the reaction here is 1/3, and here it's 2/3 due to this unit load. So you can easily verify that. Therefore, the integral at section 1, you copy EI 1 times delta C, copy the big N. Then this is now the new moment due to the unit load, negative 1/3 of x. Then the moment at section 2 is still 0. At section 3, copy the big N. Then the moment at this section is now negative 2/3 times x. Then for section 4, you copy the big N. Then the moment at this section due to unit load is now 1 times x minus 2/3 of quantity 3 plus x. So 1 times x minus quantity 2/3 of 3 plus x dx. So using a high-tech calculator, the value of the first term is negative 107, second term 0, third term negative 173, and the last term negative 4045 over 8. So combining negative 107, negative 173, negative 4045 over 8, it's negative, delta C is negative 823.125 over EI, just like before. Next, for slope at D, so we apply a unit counterclockwise couple at D1. Then computing for this reaction, this is still 1 over 9 upward, and this is 1 over 9 downward. So moment at section 1, copy the big N, EI times 1 times theta T is integral 0 to 3 of 107 over 3 times x. The moment at this section due to the reaction at 1 is 1 over 9 times x dx. Section 2, it's still 0. At section 3, copy big M. It's like that. Then the moment at this section is 1. Then minus 1 over 9 times x. 1 minus 1 over 9 times x dx. So for section 4, copy the big M. Then the moment at this section is 1 minus 1 over 9 times 3 plus x. So using your high-tech calculator, the value of the first integral is 107 over 3, second 0, third 941 over 12, and the last 4045 over 24. So combining these values, theta d is 295.125 over EI. So that's also counterclockwise because it is positive. So finally, for the rotation and for the slope and deflection of D, first for rotation, we then again apply a unit counterclockwise couple at D. So we always assume positive slope, positive rotation. So computing for the reaction here, it is 1 over 9 upward, and at D, 1 over 9 downward. So EI times 1 times theta E equals same integral 0 to 3, then copy the big N. The moment at this section is positive 1 over 9 times x dx. For the second section this time, there is a couple load, so there is now value for that integral. So the moment at this section, negative 15 times x, that's clockwise, and over counterclockwise positive. Negative 15 times x, and due to the unit load, it is positive 1 because this is counterclockwise dx. Then for the third section, copy the moment due to big N, and for small m, the moment at this section is 1, then minus 1 over 9 times x, which is that. And for the last section, copy 0 to 3, copy the big M. Then for small m, the moment at this section is 1 minus 1 over 9 times quantity 3 plus x. So using your high-tech calculator, 107 over 3, second integral negative 30, third integral 941 over 12, and the last integral 4045 over 24. Combining, theta E is 265.125 over EI. Then finally, for the deflection at E, so we have an upward unit load at E. Then compute for this reaction, AY times 9 equals 1 times 2. So that's why this is 2 over 9. Then downward reaction here times 9, moment about 8, equals 1 times 11. So therefore, 1 times 11 divided by 9, 11 over 9 downward. So for EI, 1 times delta E, copy the moment in section AB due to the actual loads. Then the moment at the section is due to unit load is 2 over 9 times x. Then for the second integral, we have copy the original moment, negative 15x. Then moment at this section 2 is positive 1 times x. Then for the third section, copy the original moment. Then due to unit loads, the moment at this section is 1 times 2 plus x minus 11 over 9 times x. 1 times 2 plus x minus 11 over 9 times x dx. Then for the last section 4, copy original big N. Then due to the unit loads, so we have moment here is 1 times quantity 5 plus x minus 11 over 9 times quantity 3 plus x. 1 times quantity 5 plus x minus 11 over 9 quantity 3 plus x. So using your calculator, the value of the first integral, second, third, then fourth. Combining, delta E is 550.25 over EI, just like before. So that's it for this video. I hope that you are able to follow the solutions and the explanations.